Good afternoon, everyone. Welcome back to the 7th semester. This is Nagarjun Reddy, and I will be handling Power Systems Laboratory for you. This Power Systems Laboratory is introduced in order to provide you hands-on experience on different aspects which you have gone through in the different theory courses from your 4th semester onwards. You have come across different theory courses on power systems, namely Power Systems 1, Power Systems 2, Power System Operation and Control. You have also gone through electives, professional electives like renewable energy systems and high voltage engineering. So in all of these theory courses, you might have seen that the power systems is a very wide area in electrical engineering, and it comprises different sub areas starting from the generation, including transmission, and ending at the distribution, along with operation and control and integration of different types of sources. So we had an opportunity to discuss with the experts from the industry, and we have identified a few knowledge areas where every electrical engineer must have a sound knowledge. And also we have discussed with them that what the skills they are expecting from electrical engineer. So we have made a list of the knowledge areas, and they asked us that every electrical engineer must have an idea about the transmission lines, how they do operate, and what are their performance characteristics, and also some basic relays. And also they asked us how to understand, how to analyze the faults which do happen very frequently in the power system. And they also asked us to enlighten the kids, particularly on the dielectric strengths of electric materials. So keeping this in view, we thought of introducing these knowledge areas in Power Systems Laboratory with the key aim of improvising your skills to determine the operating characteristics of different components of the power systems, to improvise your skill on analyzing the PV panels, which is now a hot area in power systems, because we are all integrating the renewable energy systems into power systems, isn't it? And also we want you to be able to determine the sequence components of electrical components, and also you must be able to determine the fault currents and also pre-fault and post-fault situations of power system components. And also we thought of improvising your skill to determine the breakdown strength of different electric materials. And also you must be, as an electrical engineer, you must be able to provide reactive power compensation for improving voltage profile. That is the first and foremost thing which you are supposed to learn. So keeping that in view, we have designed the course learning objectives. So these are the course learning objectives. We do have certain components in our laboratory, and apart from that we are purchasing a few more components this time. All these are being well placed in the laboratory with a single aim of incorporating industry level knowledge for you. So these are the course learning objectives, where you will be gaining suitable knowledge on performance of different components of transmission line, 2 minutes, and characteristics of protective relays and sequence impedances. So with these course learning objectives, we have decided to introduce a list of 12 experiments for you. So in these 12 experiments, 3 experiments were chosen from the power systems transmission side. Out of these 3, 2 will be on the transmission line. We do have a artificial transmission line in our department, in our power systems lab. So you will be determining the performance characteristics on that. And apart from that, you can do assessment of voltage profile on that one, and you can improve the voltage profile of the transmission line by using reactive power injection. And the other one is there are tap changing transformers also in our laboratory, so these can be employed for reactive power injection. So these three are the experiments from the power system transmission side, and we do have two relays in our laboratory. One is a static overcurrent relay, the other one is a static differential relay. So you are supposed to understand them and identify and determine their operating characteristics. Apart from that, after interacting with the industry experts, they proposed us to introduce new experiments also. So we are purchasing two more relays. So you will be having an opportunity to work on this modern relays also. And fault analysis. So first of all, for doing fault analysis, you know that we do require sequence impedances, which are not given by the manufacturer. So you are supposed to determine the sequence impedances of one static device, one rotating device. So you are supposed to do two experiments on that. And apart from that, you do have two experiments exclusively on performing short circuit analysis. So you can choose any of the two short circuit faults and you can do the experiments on that. And in the high voltage engineering, as the industry experts suggested us, we thought of having this experiment. We do have this kit in our laboratory where we can measure the dielectric strength of transformer oil. So with that same experiment, you can measure the dielectric strength of any liquid or gas insulating material. So, and apart from that, this time we are introducing RES experiments for you, because in the earlier curriculum we used to have RES laboratory, but we have removed this time because of shortage of credits. So, but we thought of introducing these things in power systems laboratory. So we do have two PV arrays in RES laboratory. Rakesh Chandra sir has given consent to do experiments on these things. So you will be doing two experiments. One is understanding and analyzing the performance characteristics of PV array, and the second thing is analyzing its performance under partial shaded conditions. Okay, so two experiments on PV arrays. And apart from that, guys, I would like to say to you one particular thing. There were two course projects which were done in 2017 and 18 by BTech graduate students. They have done live projects, and we from the power systems side, power systems faculty in our department, we decided to implement these live experiments, live projects as experiments being, so that you will be fascinated with these live projects. So two projects, determination of voltage profile and IEEE 33 bus radial distribution system, and also determination of load flows of NTPS 23 bus test system. So these two physical models are available in the laboratory, and I promise you guys, if you do any live projects also, your name also will be held like this. Okay, your live project will also be added to the list of experiments for the next time. So try to concentrate on the live projects in your final year, and the teaching learning, and you do have course projects also. Even don't think that it is a laboratory course and we don't have any course projects. We are having course projects, and those who are really interested, you can do course projects on these two things. One is the transmission line, which I already told you. You can do complete analysis. You can operate it at any voltage. You can operate it for any length. We do have 6 sections of length, and it can operate on 6 different voltages, and you can do anything on that with any of the loads. So if anybody is interested in doing all the things on the transmission line, completely characteristics of the transmission line, then I will be awarding you a course project certificate. And the other one is design of reactive power compensating device, and those guys who will do this thing, who will design a new reactive power compensating device, I will promise you that this one will be included in the list of experiments for the next academic year. Okay, and the assessment, you know that last time also we did the same. 40 marks for continuous internal evaluation. I will be monitoring your progress every lab, your attendance, and I will be keeping a slip test regularly. For that 40 marks, and 60 marks for your external examination. But my expectations: attend each laboratory class, practice the experiments through simulation also, and attempt any one of the course projects. Okay, so that's it from my side. Thank you guys. We'll meet again in the laboratory.